Hello, algebra students. Today we are going to talk about section 9.4, which is solving systems of inequalities. So let's take a look at the note document. So here is the note document that you can choose to print if you would like to print. If you do not want to print, you don't have a printer that's working right now, you'll need some paper, a pencil. It would be helpful to have colored pencils or highlighters with you or colored pens with you today, a ruler, and graph paper if you have it. If not, just do your best to sketch. Okay, remember you do not need to submit these notes. There are a couple of graphs that are hot linked in here today, right? There's one here, and then there is another one. There's another one in there somewhere. So if you want to look at the graphs a little bit larger, you have that option. Okay, so if you remember back in chapter 4, we talked about just solving systems of equations. And we started out by talking about graphing lines, and then the point where they intersected was your solution. And then we talked about substitution and elimination. Okay, but what about if you had a system of two inequalities? How can we represent that solution as a graph, and how many solutions are going to exist? So we're going to think about this first system here. Y is less than or equal to negative x plus 5, and y is greater than 2/3 x minus 1. So the first thing I want you to think about is, what would the graph of this system of inequalities look like? Okay, so this is going to be an Edpuzzle question. You may not just write IDK. Think, what is something that you can guess about the graph of this system of inequalities? Okay, so now let's take a look at the graph. Okay, so if I graph the system of inequalities, I have it set up over here. I'm going to turn my graphs on. So this is my first inequality. Right here, we know that's going to be a line with a shaded region. We know it's going to be a solid line because it's got the equal to under it. And now I'm going to turn on the second one. And so my next question for you is, which points are the solutions to this system? So as you look at the screen right here, which points are the solution to this system? In other words, which points make both inequalities true? So as you're looking at this, you see a blue region, you see a purple region, you see a pink region, you see a white region. Which of those regions do you think represents the solutions of this inequality? Okay, so hopefully you're thinking it's the purple region, right? That's the overlap between those two sections. So if I were to turn off the blue, there's just that one graph, right? There's that inequality. If I turn that one off and turn this one on, here's my other, right? So that's everything greater than 2/3 x minus 1. When I turn them both on, we want to look at the region that's doing two things at once. We want to look at the region that is less than or equal to my pink line, and so less than or equal to this pink line right here, and greater than this dashed blue line. So which part of this is doing both of those things at the same time? So being below the pink line and above that dashed blue line, and it would be this purple region right here. So that is my solution region. Okay, so now my next question is, if we only had the boundary lines, okay, if we only had the boundary lines, let me see if I look at this right here. Yes, if I only had the boundary lines, okay, there are my boundary lines. How could I figure out where my solution is if I only had the boundary lines? If I had graphed them and then I'm like, okay, well, how am I going to know which region is going to meet both of those? We're going to call them constraints, right? That's going to do two things at once. It's going to be less than or equal to my red line and greater than my blue line. So I want you to think about, based on what we did last week, how might we figure out what region is the correct one? Okay, we already know it's this over here, right? We just saw that. But how could we know which region we should be saying is our solution? Okay, so hopefully what you thought of was that we could test a point because that's what we did last week, right? We tested a point not on the line and then decided, okay, if it was a solution, we shaded on that side. If it wasn't a solution, we shaded on the other side. So the idea is any point over here in this region, any point would be a solution to both inequalities. That means it would make both inequalities true. Okay, so let's take a look at another example. So this next one, and my copy did not come out great when I printed it. It's more clear on the document. So draw a graph of the region satisfying both constraints. That means like satisfies both of those inequalities. And start by graphing the boundary lines. And then we're going to use that idea of testing points to find the region that makes both inequalities true. Okay, so we're going to start by graphing the inequalities. And these are both lines. Okay, so I'm going to graph the line y equals x plus 2. Okay, if it's just a plain x, that's like there's a 1 in front, so my slope is 1 over 1. That's my change in y over change in x. And my y-intercept is 2. And this inequality tells me I'm going to have a dashed line. Okay, so I'm going to put a point at 2 on my y-axis. My change in y is positive 1, so I'm going to go up 1. My change in x is positive 1. I'm going to go to the right 1. And I'm going to do a handful of these so that I get a nice accurate line. And then I'm going to draw a dashed line, I found a ruler, through those points. It really is important that you're doing this right now, okay? So it's fine to watch me, but that act of actually doing it is going to help it to stick in your brain better, and you're going to want to have these notes to refer to. Okay, so here is my first line. I'm going to just highlight it in orange so I can keep them straight here moving forward. Okay, my second line that I'm going to graph is this y equals 5 minus 3/4 x. Not quite in y equals mx plus b form. The x is second. Remember, the slope is always what's in front of the x. So my slope is negative 3 over 4, and my y-intercept is 5. Okay, so I'm going to go to 1, 2, 3, 4, 5 on the y-axis. My slope is negative 3 over 4. That means I'm going to go down 3 and to the right 4. Okay, and this is, because it's got the equal to underneath, going to be a solid line. Okay, so I'm going to draw a solid line through those points. Oh, let's see, how about blue? I'm going to highlight that just to keep it straight. Okay, and that's going to be this line here. So right now, how many regions is my plane, right, my axis, my coordinate plane, split into? Okay, so take a close look. I'm going to give you an Edpuzzle question in a second. How many regions do you see this split into? Okay, hopefully you see 4, right? You see this one over here, we could call this region A. You see this one all over here, we could call this region B. You see this one over here, region C, region D, okay? 4 different possible sections that could be my solution set. And so what we said that we would do before when we were graphing an inequality is we would test a point to see if it works or not. And we're going to do that same thing here. I'm going to pick the point 0, 0. We're going to pick a point not on the line. So in this case, I'm going to pick the point 0, 0, and I'm going to see what happens when I substitute them into both inequalities. So I'm going to pick the point 0, 0. First, I'm going to put it into the y is less than x plus 2 and check and see if it's true or not. 0 is less than 0 plus 2. Is 0 less than 2? It is. Okay, so this is a solution, right, to this one. Because I want to shade on the side with the 0, 0. So that means shade on the side with the point 0, 0. Okay, now let's see what happens when I put it into this one. Okay, so when I put it into this one, I'm going to have 0 is less than or equal to 5 minus 3/4 times 0. So 0 is less than or equal to 5 minus 0. Is 0 less than or equal to 5? It is, right? Okay, so again, that 0, 0 is a solution. So I'm going to shade on the side of 0, 0. All right, and then the overlap between those two regions is going to be my solution. So let's see what that looks like. So here's my point 0, 0 that I tested out. Here's my orange line, okay? For my orange line, I want to shade on the side that includes the point 0, 0. So that means I have to shade down here, kind of beneath the line. As best you can. I'm not going to color it all the way. It just take a little bit too long. Okay, so now for my blue line, I want to shade on the side of 0, 0. Here's my blue line. Point 0, 0 is over here on this side of the line. I want to shade on this side of the line. Everything on this side of the line. Okay, my solution is where my orange and my blue overlap. Okay, so my solution is where the orange and blue overlap. Okay, so just make sure when you're doing your practice assignment on Thursday and you have to do these types of problems that it's very clear where your solution is. Right? Now, if you don't have colored pencils or markers or anything, crayons even, that's fine. Maybe what you do is you shade one way like vertically and then you shade the other way horizontally, and then where you have the hatch marks, then that's your solution. Okay, and if you just darken that in just to make it really clear where your solution is, that's fine. Okay, so all of this here is my solution. So it's fine to not have colored pencils. Sometimes it helps just be able to see it better. But if you don't have them, just go like vertical, horizontal, and then the cross marks are where you have your solution. Okay, so let's take a look at the next one. Okay, so our solution ended up being this region C here. Okay, this is my note to myself to remember to do this. So now, when graphing this system here, the system of inequalities below, Raina started with the boundary graph of each constraint. Okay, so here we have, here's my first inequality, that's this parabola here. And then this equation here, this y, or inequality, y is greater than 2/3 x, that's this dashed line here. My first question for you to think about is, why is the line dashed, but the parabola is not? Okay, so take a look at the graph. I'm going to ask this Edpuzzle question. Why is the line dashed, but the parabola is not? Think back to what we talked about last week. Okay, the next thing I want you to think about, how many possible solution regions are there? So take a good look at that graph. How many solution regions are there? Okay, so hopefully you've said that you see 5. I'm going to label them. So A, B, C, D, E, right? So everything up here is a region. Everything like between the line and the parabola out here is a region. Everything in here is a region. All of this stuff out here is a region. And then up here is a region. So there are 5 different regions. Okay, so now I want you to think about, how do you think we could figure out which regions or region contain the solutions to the system? What do you think we could do? Okay, so what we're going to do is we're going to start by picking a point in each region and testing it in the system of inequalities. Okay, and then we'll shade any regions that contain solutions to both inequalities. So here, I'm going to do the first 2 regions with you. I'm going to show you those, and then I'm going to ask Edpuzzles for C, D, and E. So please make sure you're paying attention to the process so that when you're asked to do it on your own, you feel like confident that you can do it. Okay, so let's start with region A. I'm going to pick a point in region A. It could be any point in here. I'm going to try to pick one that's pretty easy to work with. Okay, so I'm just going to pick this one. I'm going to pick something up here where one of the values is 0 just because it's easier to work with. So I'm going to pick the point 0, 4. And now I have to substitute that into both of these inequalities up here, both of them. Okay, so because I am going to ask you to do them for C, D, and E, you might want to, if you haven't already, to jot down these inequalities if you haven't printed out the note sheet. Okay, so First, I'm going to substitute in I'll write it down here. Y is less than or equal to x squared plus x minus 6. So I'm going to put 4 in for y. I'm going to put 0 in for x. And let's see what happens. So I have 4 is less than or equal to, well, that's 0 plus 0 minus 6. That's not true, right? I actually don't even need to plug my ordered pair into the second inequality because it's not true. If it doesn't work in both inequalities, it's not a solution. And it didn't work in that first one, so this is not a solution. Okay, so now I'm going to go back up here and I'm going to pick a point in region B, which is this region here. Okay, I could pick any point I want, not on a boundary graph. Okay, so maybe I pick this point here. Maybe I pick -4, 0. And I'm going to start out again by substituting it into the first inequality and see what happens. And then if it works in that one, I'll double check it in the next one. So I'll have 0 is less than or equal to -4 squared plus -4 plus 6. Okay, notice that I have put the -4 in parentheses before squaring it, right? Because I want to think of it as -4 times -4. So that's 16, and then that's -4 plus 6, which is minus 6, sorry. -4 minus 6 is actually -10. So is 0 less than or equal to 6? It is. Okay, so this point is a solution to the first inequality. Okay, now I need to put it into the other inequality, which is y is greater than 2/3 x. Okay, so I'm still putting the same point in here. So y is greater than 2/3 times -4. So is 0 greater than, this would be -8/3. So is that true? Or I'm sorry. Why do I have this wrong? Yes. Okay, that is true, right? 0 is greater than -8/3. Sorry about that. I had something else written down. I'm not sure what I did before. I think I wrote down the wrong inequality. Anyway, so just happens, guys. This isn't perfect production here. Okay, so this right here is true, right? Okay, so those are both true. And so what that's going to mean is that this is a solution to our inequality, right? And so if that's a solution to our inequality, then what that means is that this region B here is part of our solution. Okay, and just so you guys know, sometimes it's only one region is part of your solution, and sometimes it's more than one. So you might be thinking, oh, we're done, sweet. Okay, it could be that there is another region to this that's a solution. So we do need to continue checking them. And when it's 2 lines, it's usually just one, but with curves, it can be more than one. Okay, so now what you are going to do is you're going to go through that same process. You're going to pick any point here in region C and check and see if it makes both inequalities true. You're going to check anything in region D, any point, pick one. You're going to pick anything in region E and see if it works. Okay, and those are going to be Edpuzzle questions. Okay, so now as you went through that process, you should have found that region C did not work, right? It worked in the first inequality, but not in the second. Region D did not work, right? It didn't work in the first one. You didn't even have to try it in the second one. Region E did work for both of them, right? So region E did work. So this was also part of your solution. Okay, so you see here, this had 2 parts that were true. So how many regions make up the solution? 2. Right now, why is 0, 0 not a good point to use to test for the solution? So the first example I did, I used 0, 0. A lot of the times in last week's Edpuzzle, we use 0, 0. Why in this case do you think, look at that graph again, why did I not choose 0, 0 this time? Hopefully you said the reason I didn't choose 0, 0 is because it's on one of my boundary lines. Okay, and I want to know something like being greater than or less than. I don't want it to equal. In this case, it can't equal 0, 0. So that's why we didn't choose it. So hopefully you recognize that. All right, so now the next question is, how does changing the inequality affect the solution graph? So I want you to look at these 3 sets of inequalities. You need to pause so that you can zoom in or jot them down. do that or pull up the notes so that you can see them more clearly. I know sometimes the Edpuzzle videos are small. What similarities and differences do you notice among the systems of equations below? This is going to be an Edpuzzle question. You may not just write they both have x's and y's in them. I know that. Okay, you need to dig a little bit deeper, please. Okay, so take a minute to do that. Okay, so probably things that you noticed is that the top inequality always involves this expression x squared plus x minus 6. All of them do, right? The second inequality always is relating a y to a 2/3 x. You can look at the graphs and see they're the same boundary lines. Okay, but what are the differences? Okay, looking at the inequalities, they're all different, right? And if we look back at the one that we just did, it's the same inequalities as what we just did. This was a less than or equal to and a greater than. Okay, so it's just different combinations with all the different possible inequalities. And so what we want to do is think about how could we devise a method to determine which region or regions are solutions for each system. And then we want to shade the appropriate region for each of them. Okay, so what we had just done was we tested a point in each region. And it's a lot, right? To do that for all 5 regions for every single one of these, it's kind of a lot, right? So what we're going to do is we're going to just pick one point and we're going to test it in each of the regions, we're going to test it in each of the inequalities and use that same thinking that we did last week, that if it makes the inequality true, we're going to shade on that side of the boundary graph. And if it doesn't make the inequality true, we'll shade on the other side. Okay, so that's the thinking that we're going to use for this one. So I already know I can't pick 0, 0. And I really can pick the same point for all of them. I just need to look at them a little bit differently. So I'm going to pick, it literally doesn't matter. I'm going to pick something involving a 0 though, because it's faster. And I'm going to pick 0, 4 because I picked that a minute ago and that was pretty easy to work with. Okay, so the point 0, 4 is the point that I'm going to substitute into each of these inequalities. So here, when I plug in the 0 and the 4 in this first one, I'm going to have 4 is greater than or equal to 0 squared plus 0 minus 6. And I'm going to get the inequality relating 4 and negative 6. And here is 4 bigger than or equal to negative 6? It is. Okay, so I'm going to shade for this inequality, which is my parabola. I'm going to shade on the same side as the 0, 4. So I'm going to shade on the side of 0, 4. Okay, that means that I'm going to end up shade. So there's 0, 4. That means I'm going to shade inside. Okay, so now for this next one, I'm going to plug in that point 0, 4. So the 4 is going to go in place of the y. And I want to know, is that bigger than 2/3 times 0? Is 4 bigger than 0? It is. Okay, so because 4 is bigger than 0, that's true. I'm going to shade on the side of 0, 4. So looking at my dashed blue line, I'm going to shade on the same side as my 0, 4, which is going to be all this stuff up here. My solution is which region? Okay, so which region do you think is my solution? Hopefully you're thinking, oh, it would be the region that has the A, or not the A, it is region A, but it's the region that has where it's blue and orange, which is region A. Okay, so that's my solution in this case. It's the section right here. Okay, so you guys are going to take a minute. You're going to go through the same process with B and C. Okay, and you could use the 0, 4 again as your point, right? And you're still going to have the same result. You're going to be comparing a 4 on the left to a negative 6 on the right, but in this case, it's greater than or equal to, which is the same as the last one, right? So we know that this is the same for this one here. Okay, now in the second one, it's going to be the same. It's going to end up being the same result here. I'm going to compare 4 to a 0, but now it's less than. So you should be thinking, is 4 less than 0? No. Okay, so that means you're going to shade on the side without the 0.04. Okay, and I want you to think about what region that would be. Would it be A, B, C, D, or E? Okay, and then my next question is going to be for you to go through the same process with system C. You could use the 0.04 again, or if you choose, you may go ahead, give it a whirl, do something else. Okay, so try those two problems. Okay, so for this first one, we said we would shade on the side of the 0.4, so we would be shading here. For the second one, we said we would not be shading on the same side, so we would be shading down here. And our solution is where we have them overlap, which would be this kind of funky spot here, right? So it was region D was our solution. Okay, for this one, when you plugged in and you compared the 4 and the -6, is 4 less than or equal to -6? No. So that means I don't shade on the side of the 0.4 for my parabola. So here's my parabola. That 0.4 was not a solution. That means I have to shade outside. And for this guy here, when I compare, what was I comparing? A 4 and a 0. Is 4 less than 0? No, it is not. Right? So then I would not, so for this line here, I would not shade on the side with the 0.4. I would shade on the other side. And my solution is the region where my orange and my purple, or my orange and my blue rather, overlap. So here, which is region C. Okay, so rather than picking all 5 regions and testing 1 point, which you can totally do, it gets tedious though. 5 regions is a lot, and most of them have at least 4. Sometimes they're less, it's not always 4, but it seems like a lot. You could just pick that 1 point, and then if it is a solution on that side, and if it's not, then the other side. Okay, I have that summarized down here, and then we're going to do a few examples. Okay, so first thing we're going to do is graph the boundary line. Remember, keeping track of should it be or not positive, but solid or dashed. Choosing a point to test that doesn't lie on a boundary graph, plugging that point into each inequality. If it makes the inequality true, shade on the side of the boundary line graph that contains the point. If it makes the inequality false, shade on the side of the boundary graph that does not contain the point. The solutions are represented by the overlap of the 2 regions. All right. So now, my questions that I have to remember to ask you guys. Okay, so now we're going to try some. I want you to look at this first one. Before we even graph it, what do you notice about the slopes of these lines? So we're talking about y equals 2/3 x plus 3 and y equals 2/3 x. Hopefully you notice that the slopes are the same in both equations. So my next question is, what does that mean about the lines? What do you remember from last semester about lines that have the same slope? Okay, I just jotted down my y-intercept here is 3. Here I don't see anything written. Remember, that means our y-intercept is 0. Hopefully you said, because the slopes are the same, we're going to have parallel lines. Okay, so let's take a look at this. My first line starts at 3. I have a slope of 2/3, so up 2/3. Solid, right? Both of these are solid lines. We don't have to worry about screwing this up. I'm always worried it's supposed to be dashed, and I forgot to make it dashed. Okay, so that's my first one. And then my second one starts with a y-intercept of 0 and is up 2/3. So my next question for you to think about is, well, how many regions is this? My ruler is not straight anymore. It's like chipped, so I get non-straight lines. How many regions did our boundary graph split this coordinate plane into? So hopefully you're seeing that there are 3. I'm going to call them A, B, and C. Okay, 3 regions. Now, we want to figure out, well, where's the solution at? So what we're going to do is we're going to pick a point not on a boundary line. So I cannot pick 0, 0 because my boundary line goes through 0, 0. I have to pick something else. Anything you like, you could pick 3, 1. You could pick -2, 0. You could pick 0, -1. You can pick anything you want. It makes no difference at all. Like I said, I try to pick things where if I can have a 0 involved, just less work. Okay, so let's say that we choose to pick the point 0, 1. Right, I'm just going to pick this point here to test 0, 1. And let's see what happens when I plug the point 0, 1 into each of these inequalities. Okay, so if here I put a 1 is less than or equal to 2/3 times 0 plus 3. I'm left with 1 is less than or equal to 3. Is 1 less than or equal to 3? It is. Okay, that means for my orange line, I'm going to shade on the side that contains the point 0, 1. So here's my line, here's the point 0, 1. I want to shade on the side that contains the point 0, 1. Okay, so there's that. All right, for my line B, if I plug in 1 for y and 0 for x, I get 1 is greater than or equal to 0. Is 1 greater than or equal to 0? It is. Okay, so that means that I'm going to shade on the side that contains the point 0, 1. Here's my blue line. Here's the point 0, 1. I want to shade on this side. So here's an example. If let's say you didn't have colored pencils right now, when I do my shading, I'm going to kind of go like this horizontally. So if you were using just pencil, where would your solution be? Okay, so think about what region is your solution, A, B, or C? So our solution is this crosshatch here where I've got my blue and my orange, everything in between. Okay, so this is my solution. Okay, so let's try this next one. You should be doing this, right? You should be graphing each of these boundary graphs and thinking on your own, okay, where's the solution? Okay, so for this first one, I have a slope of 3/4 and I have a y-intercept of -2. So here's my -2 up 3/4. I'm going to also go down 3 back 4. It's a solid line because of the equal to. So let me draw that. Oh, this ruler's terrible. Okay, so that's this guy here. All right, then my other line has a y-intercept of 3 and a slope of -1/2. So this is my y-intercept is 3. My slope is -1/2. So that means from here, I'm going to go down 1 to the right 2 a couple of times, and I'll go up 1 to the left 2. It is a dashed line, right, because it doesn't have the equal to underneath. So let's be careful to make it dashed, not solid. It's one of the easiest things to screw up on these is to draw your line the wrong way. Okay, there's my line. Okay, so first, how many regions? Hopefully you're saying 4, right? I'm going to label them A, B, C, and D. Now it is your job to decide which region it is. Okay, so that's my question to you. Which region or regions are the solution to this system of inequalities? Okay, so let's see how you did. So I would have picked a point, any point, and I get to use 0, 0 if I want to right now, so I'm totally going to because that's easy. Okay, I'm going to pick the point 0, 0 and see if it works or not. Okay, so if I put 0, 0 into this first one, so I have 0 is greater than or equal to 3/4 times 0 minus 2. So is 0 greater than or equal to -2? Yes. Okay, so for my orange line, I shade on the side that contains my point 0, 0. So for my orange line, I am going to shade on this side. Okay, so now for my blue line, plugging 0, 0 in again. Let me jot that down. That's what I picked up here. 0, 0. Okay, so 0 is 0 less than -1/2 times 0 plus 3. So 0 less than, will that be 0 plus 3 is 0 less than 3? It is. Okay, so then that means for my blue line, I have to shade on the side with the 0, 0. okay, which means I end up shading underneath the line. Okay, our solution is the overlap, right? Which is where I have the orange and the blue. So hopefully you guys said for your solution is that your region was B. If you didn't, that's what you should have said. All right, last example. So first thing we're going to do is we're going to graph those inequalities. The first one is a parabola. It's our parent function. That means it's our most basic parabola. So that's a quick one, right? You might even think about when you're graphing it as just doing a quick table, right? If I square -2, I get 4. If I square 1, I get 1. 0 is 0, 1, 4. So it's just a parabola with a vertex at the origin, right? Just the basic one. It is going to be dashed. Okay, careful on that. So easy to just draw them in solid because that is really what we're used to doing. Right? Except for when we talked about discrete, right? We talked about not connecting things earlier in the year. This is a little different though. Okay, so there's my first one. My second one is a line, right? This is going to be a line with a slope of 1 and a y-intercept of 2. So I'm going to start at 2. I've got a slope of 1. So up 1, over 1, down 1, back 1. It is a solid line. Yes, okay, did that right. So this one here, solid line. All right, so how many regions do you see that we're going to have to worry about? All right, I see 5 again. So I'm going to call this A, this B, this C, this D, this E. Okay, and so we are going to go through that same process. I'm going to have you pick a point. It cannot be on either our boundary graph, so we cannot pick 0, 0. You're going to pick a point. You're going to plug it in, see if it works or not, and you're going to tell me which region do you think contains the solution or solutions. It could be, remember, more than one region. We saw that happen once before. Okay, so give that a try. Okay, so let's see how you did. What point did you pick, I wonder? There are so many possibilities. I don't want to pick a negative because I can screw that up. I'm going to pick the point. I'm going to pick up here. What's this one? 1, 2, 3, 4. I'm going to pick the point 0, 4. I picked that one a few times. That must be my new favorite. Okay, so I'm picking the point 0, 4, seeing if it gives me a solution or not. So if I plug 4 in here, is 4 less than 0 squared? Is 4 less than 0 squared? It is not. Okay, so that means that I'm not going to shade for my parabola, my orange graph, I'm not going to shade the side that contains the 0, 4. I'm going to shade on the other side of that. So it's going to be all this stuff over here. All of this. Okay. Then for the next one, I'm going to plug in 4 for y. Is that greater than or equal to 0 plus 2? So that's 4 is greater than or equal to 2. Is 4 bigger than or equal to 2? It is. Okay, so for my blue line here, I'm going to shade on the side that contains the point 0, 4. So I'm going to shade on this side of my line. Okay, my solution is where I'm orange and blue, which ends up being here, like all this, and all up here. So hopefully you said your solution is in regions A and C. Okay, that's it, ladies and gentlemen. Please, if you're having difficulty, please come to office hours. Please, if you know you didn't do well on the Edpuzzle, you will be asked to submit your notes and rewatch the video. So please be prepared for that. Take care, algebra students.